Okay, so let's talk about the structure of the universe. Now, when I say the structure of the universe, what I'm referring to is the levels of organization that we find in the universe at large. And so we're going to work our way up. We're going to start at smaller structures, and then and kind of build up to the larger structures. It's kind of like, if you're sitting at a computer and there's a table in front of you. At the smallest level, we know that the table consists of atoms. Then those atoms bond together to make molecules, and then all those molecules are bound together to create the table. And so there's different levels of organization there, and that's kind of what we're looking at in this video when it comes to the structure of the universe. Now, the first thing I wanted to show you was a neat picture. If you followed the news at all here the last year, you know that there was a big advance in astronomical research, and that came with the James Webb Space Telescope that was launched into space within the last year. Now, this is a deep field image. It's the first deep field image that the James Webb telescope sent us. I want you to understand this picture. I've got it large, but it actually is a picture that's just looking at about 1/10,000,000th of the entire sky. And everything we see in here, except for the brightest points at the front, let me talk about this. The brightest points with spikes here, these are actually stars in our own galaxy. So, but everything else you see here, anything that's got, well, let me say it this way, anything that's got these spikes on it is a star that's in our galaxy. But everything else that you're seeing is a galaxy itself, okay? So this is 1/10,000,000th of the sky. I mean, if you were to sit down and count the number of galaxies that we have in this, multiply that by 10 million, then you would have a sense of the total number of galaxies in the visible universe. So it's an amazing picture. Now, these white fuzzy areas here at the center, right in here, these are elliptical galaxies. And it turns out that these galaxies are bound together, which is another level of structure that we're going to talk about, but they're bound together by gravity. All right, and they form what's called a galaxy cluster. Okay, now the neat thing in this image, I wanted to point this out, is that the gravitational influence of this galaxy cluster actually causes the light that's sent from the galaxies behind it to go through what's called gravitational lensing, and you see it in the distorted shapes. It's really interesting. Light, even though it doesn't have mass the way a rock has mass, it still has a mass associated with it. And so the gravity created by this cluster is able to actually bend the light. And the light that's coming really close is undergoing gravitational lensing. And what that leads to is double images of a galaxy. So if you look here at this little band, this arc right here, you see what looks like a galaxy here. There's the center. And here's another galaxy with its center. Well, that's actually the same galaxy. It's just that the light is getting bent as it comes around this galaxy cluster, and the lensing produces that double image, the arc. We've got another one over here. This galaxy here and this galaxy here, well, that's actually the same galaxy. So that's kind of cool. That was one of the things that verified that Einstein was right in his general relativity, was that light should bend as it goes around, really massive objects or massive galactic clusters. And so we can see that, and I wanted to point that out. Now, what's really cool is that if you look at the image closely, you can see a lot of star clusters forming along the edges of some of these galaxies. I created a little inset here. So I've taken this little piece, cut it out, and expanded it. And so this piece right here, this galaxy, that's this. Well, if you look at it, you see all those bright orange dots? Well, those are actually areas where you have globular clusters of stars that are in the process of formation. All right? And one of the cool things is that we're looking at this galaxy as it was a long, long time ago. We'll talk about that. And so it's just really cool. You can see all that. Now, the big reason I shared this picture with you, though, is that when you look at the universe, even this small little piece, it just looks like this random, chaotic assortment of galaxies and stuff, And so it can lead you to think, hey, man, it's just out there, it's random, there's really no structure to the galaxy. And yet the fact is there are structures in the galaxy, these levels of organization. Now, I'm going to go through 4 of those. I will say there are levels that we could put in between some of these, but I don't want to go over everything. I want you to have the big picture, and so we're going to look at a few levels of structure that are important for grounding us and understanding how the universe is built. Okay? So, the universe possesses different levels of organization. And the first level is what I call a solar system. Okay? Well, what anybody would call a solar system, or you might hear it said a star system. Okay? This just consists of a single star. Sometimes it could be 2 stars, binary star systems, but it's usually a single star that has 1 or more planets of various sizes, different compositions. These planets may or may not have moons. The solar systems also tend to have these dwarf planets. You know, Pluto is a dwarf planet in our solar system, but also comets and asteroids. And really, I could have put in there, you know, just dust and stuff in space. But that's what makes up a solar system. It's a star that gravitationally binds planets so that they orbit it. Those planets have moons, and then we get these other wild things like comets and asteroids that are really, we're going to find out, the leftovers from the formation of the solar system. So that's the first level. And I do want to share a picture with you that's just out of your textbook. It's a picture of our solar system. I do believe they tried to draw this to scale as far as distances from the sun, maybe, but it's definitely not to scale in terms of sizes. So, but this is our solar system. Here's the sun at the center. Here are the planets. Jupiter is definitely not bigger. I'm sorry, Saturn is definitely not bigger than the sun, so that's not drawn to scale. But then out here is what's called the Oort cloud, which is basically a bunch of space junk that forms a spherical shell around our solar system. Oh, and I should point out here, too, that we have between Mars and Jupiter an asteroid belt that circles the sun. And so that's a solar system. That's a level of organization. And the cool thing is we're discovering, we're discovering that, you know, there's a lot of solar systems in our galaxy. Most stars have planets, and we're actually able to detect those now. The second level that I want you to think about then is galaxies. You know, a galaxy just consists of billions of stars, most of which are orbited by planets, and these stars are gravitationally bound together. And there's also dark matter in there, and everything's orbiting a centrally located supermassive black hole. But a galaxy is just a large group of stars that all kind of stay together because of their attraction to that black hole at the center of the galaxy. Okay. Now there are 3 main galactic shapes that we find when we look out there. We've already seen an elliptical shape in that James Webb telescope image. And here's an actual elliptical galaxy, a picture. This is just the way they have to name things. I'm not going to say all that. But this is a picture of an elliptical galaxy. It's got this kind of oblong egg shape. Okay? Now we also have spiral galaxies. And here's a picture of a spiral galaxy, M101. M stands for Messerschmitt, by the way. That's just, he was a guy that cataloged, before they even knew what these things were when they saw them in telescopes, he was just cataloging them, and he gave what he found names. Well, M101 turned out to be a spiral galaxy. And then we have sometimes these irregular galaxies. NGC 1569 is an irregular galaxy. It doesn't have any nice shape to it. It's just kind of doing its thing. But a lot of times when we see these are galaxies that we find much further away from us, and so much further back in time when we look at them. And so that's the second level of structure. Now, the third level of structure I want you to know about are galaxy clusters. What a galaxy cluster is, it's just multiple galaxies that are actually bound together by gravity. Let me show you a picture. Well, a picture here. And this is a picture of the galaxy cluster Able 2744. It's also called Pandora's box. And what they've done in this image is they've kind of outlined and hazed in the blue to show you the stars, the galaxies that make up this galaxy cluster. But all of these lights, these things here, and a lot of these look like elliptical galaxies from this picture, but they're all gravitationally kind of bound together. Now, the picture can be misleading. You know, it makes it look like this galaxy here and this galaxy are relatively close. Well, they're not. The distance between here and here is massive. But gravity is a long-range force. It reaches way out there. And so despite the fact that they're so distant from each other, they're massive enough that their gravitational force still keeps them in one another's vicinity. And so you tend to get these groupings of galaxies, and we call those galaxy clusters. Now, the number of galaxies, you can have hundreds, 10, you can have thousands. Now, the bigger galaxy clusters, like thousands, we tend to call those super clusters, but I didn't want to introduce another term. So we got galaxy clusters, and they can really vary in size. And so there you go. I kind of jumped ahead on some of my points here. Now, I do want to point out that you're going to hear a lot of times astronomers will refer to our local group. Well, what's the local group? Well, the local group consists of about 30 galaxies, one of which is our own Milky Way galaxy, that are kind of bound together the same way this Pandora's box over here is bound together gravitationally. The Andromeda galaxy is the galaxy that's nearest to us. Based on the motion of those galaxies, the two galaxies are actually going to pass through each other way far off into the future. But they're on a collision course right now. But that's when we talk about our local group, we're talking about the galaxies that we form part of a cluster with. And there's about 30 of them. By the way, if you research that, you'll find different answers to how many galaxies. So I took this off the NASA website as far as the number of galaxies, but you may find some varying numbers and opinions on that. Okay, so what have we learned about structure? Well, what we've learned is that we can build up levels of structure. We have solar systems, then we can go out and talk about, and solar systems have stars, then we have these stars with their planets grouped together into galaxies, and then galaxies can hang out with one another. We got galaxy clusters and superclusters, and then of course we end up putting all that together. That's our entire universe. And the idea is that as we move from the solar system out to the entire universe, we're moving from small to larger to vast. Now, I do want to say this. Small is relative. In other words, solar systems are small compared to galaxy clusters. But based on our experiences every day, solar systems are really large. They're big. So that's why I put vast down here. The size of the universe is almost incomprehensible to us. And we'll talk about that in the next video, I believe. Or no, that'll be 2 videos away. But so here's kind of the summary. These are the structures. And what I'd like you to be able to do, remember those objectives, is just discuss how this structure builds up and be able to talk about, what is a solar system? What is a galaxy? What are these galaxy clusters and superclusters? And, how do they all fit together to form different levels of organization? Okay, so that's it for this video. If you have any questions, let me know.